Hello, welcome everybody. Welcome to today's webinar. Good morning, good afternoon, depend where you are on the planet. Today we are all together to discuss about hydrogen role within renewables and decarbonification or decarbonation, depend the wording you are using. Two elements just to start and to give you a little bit a piece of news as we can move around now again thanks to a decrease of COVID cases. Tomorrow we will start. Will be present at the conference IVS in Bergamo in Italy, and next week we'll also be in Hanover fair in Germany. So if you are going to one of those two fairs, do not hesitate to shoot us an email or a text so we can have time to sit together. Anyway, just taking the opportunity to share with you our agenda. So if we can meet, that's even better. To start today, of course, we'll start by some big news. Today we'll discuss mostly on hydrogen, but of course our next webinar is already planned and it's already on the pipe. It will be on July 5th. So it will leave the July 4th to our American friends for free, and the following day we'll talk about oil and gas, petrochem market outlook. So it is to take the opportunity at the end of halfway through the year to say, okay, what has been happening over the first 6 months of the year, what will happen on the following 6. And of course, you can find the invitation either in the slide, but also in the conversation of this meeting. You can find directly the link to subscribe and get your invitation from that. Just few rules to remember. If you have any question regarding the webinars, regarding the slide, we'll address all the questions at the end of the presentation. In the meantime, during our presentation, you can already start to ask your question. Then if you're interested by the slide that we are going to use today, do not hesitate to shoot me an email at guillemjean@tobefirstconsulting.com, and I share with you the slide. If you want to see the replay of this webinar, it will be also available on our LinkedIn page and on our website. So now I'm going to end the presentation to Jean-Charles, which is already connected normally, and we'll come back later on to halfway through the presentation. Your turn, Jean-Charles.
Thank you, Jean, for this introduction, and thank you everybody for joining us again today. Most of you are used with these webinars now. We see a number of names of regular participants, and you are most welcome to do so. We thought it important to make again a webinar about hydrogen as we did about last year, and just to review where we are compared to last year and how we see the future. So, of course, we'll start the presentation today by a short introduction about the company, about the database for people who are not yet familiar with. And then the agenda will continue with a key usage of hydrogen, very quickly, very overview, and then what are the open questions still pending regarding this hydrogen from technology and business development point of view, and as a consequence, how we should see hydrogen market in the future. So that's the agenda we propose to share with you today. Briefly, now, again, a short remember regarding the company. Most of you know the company pretty well, so I will go very quickly on this, just to remind you that we are a family company of engineers from different profile, from different horizon, but accumulating years of experience in oil and gas and petrochemical, and today now in energy transition through different companies that you can see here. Then regarding the database, the key logic of the tool, as you know, historically is of course to focus on oil and gas and petrochemical as we do for 10 years now, but for 2 years now also to develop all this energy transition part, which cover electrification, carbon capture, hydrogen, solar, windmill, power generation, water treatment, and that is this part that we are going to explore to share with you our market analysis, our data, and draw some conclusion for short term and long term. Thank you, Jean. Regarding hydrogen in the database, you will find all this specific application upstream, which is about the production of hydrogen. It can be gray, blue, green. It can be from waste, or it can be from wind. The midstream part, which is of course very important as well. It can be terminal, pipeline, storage, and tanker for transportation. But also, and that's one of the key topics for today, all the usage of hydrogen on the downstream side. And like we see actually in the database for ammonia and methanol, it can be blue, green, or ammonia terminal, and same for methanol. And we'll go deeper in the detail on this presentation today of those applications and how they develop today. Just as a reminder, on June 2021, so last year, we had already, as I said, a webinar about hydrogen, which is available on the website. So covering needs, technology, market today, as last year it was looking like. And with perspective for 2030, you will see from the presentation today that, of course, number of those perspectives we had detected already last year are materializing, some faster than expected, by the way. And that's one of the key conclusions, I would say, to take away from today's webinar. And we'll explain you in more detail what it is about and regarding those developments. Regarding the usage of hydrogen, in fact, there are two clear different categories of project and application. If we look back a couple of years ago until maybe even last year, hydrogen was mostly seen as a goal for clean fuel. The idea or the dream was really to use hydrogen to replace oil and gas for especially what we call heavy mobility, which is about truck, train, marine for vessel and planes, using hydrogen as a replacement of oil and gas for moving. Same for power generation. Even for heating, it can be home, it can be industries like steel industry, or even for cooking at home, using hydrogen everywhere, as today we use, as I said, oil and gas. But unfortunately, this vision is still valid, no question on this, but it's going to be a long-term process, because the advantage of this solution is, of course, to have no CO2 emission anymore. So that's a great advantage, and that's why this scenario is interesting a lot of people. But there are a number of disadvantage, or at least a barrier to this development. The first one is related to the low energy density of hydrogen compared to oil and gas. So you need a massive quantity of hydrogen to heat or cook or transport vehicle in the same way. From technology point of view, we are far from there. It requires massive investment and development on that. And those development has to to take place in the production through solar or wind or whatever, but also for the distribution, because the existing infrastructure are not compatible with 100% hydrogen transportation. And same for the usage, because airplane engines, for example, are not designed and will not be available before decades to replace jet fuel, for example. And the production of this hydrogen at that large scale require large spaces that you can't find nearly in Europe, maybe except in Spain and maybe in Denmark. But anyway, the rest of the world would be for this to support such a mass of production, should be in Middle East, should be in Australia, in USA, at least, not to say empty space, but at least large space to support this. Maybe offshore, that's also possible, but same with the escalation of the cost. So this first option is really a long-term vision that will happen, no question, but it will take a decade, and we don't anticipate that hydrogen should become a clean fuel used in the same way as oil and gas before 2030, most likely 2040. In the meantime, hydrogen, we can see, is massively used for decarbonation, where, in fact, hydrogen is used as intermediate molecule or intermediate blocks as a mean for decarbonation. And it can be for biomass, it can be for green ammonia, green methanol, for waste recycling, the production of syngas or e-fuel, the production of sustainable aviation fuel, etc., etc. We can find a very long list of those applications in the industry today, and this list, even in Project Smart Explore, is extending nearly every week with new application where we see hydrogen being combined with other molecules for decarbonation. And here is really a very short-term business, a daily business today, with a purpose to cut CO2 emissions. So the benefit is immediate, I would say. It uses available technologies, not necessarily very complex development. It required to use existing infrastructure, especially for distribution usage. As I said, the impact is immediate, limited investment, and it is economically viable. It can be for greenfield project, but more interestingly, for the decarbonation of existing facilities in Europe, for example. Therefore, that will involve quantities of brownfield project nearly next door to every one of you here sitting in US or in Europe. The minus, or let's say the limit of this application, of this process, is that, of course, we cannot decarbonate totally those applications. It means that it still remains somewhere at the end some CO2 emission, far less than today. So it is still valid, but anyway, of course, it's not as the same efficient today as it could be a complete usage of hydrogen to replace the carbon chain. So that's why here we want to make a clear difference between this long-term application, as we said in the previous slide, and the short-term application that we see today, where the market is booming. So next slide. Voilà. And here we have an example of this application coming up now, and especially in Europe. And we took here this example in Hamburg, in Germany, where we can see how hydrogen is combined with offshore or onshore windmill and solar, with a power plant to be decarbonated, with marine transportation to be decarbonated, with airplane being decarbonated, and so on, combining all technologies and all know-how, existing know-how, and providing immediately a decarbonation of those applications. And so we shall see the multiplication of those hydrogen hubs in different places, mainly in airborne, but not only. Everywhere there are industrial area where decarbonation should be proceeded on, let's say, on a short fast-track project. Then the dynamic in this case of the production of hydrogen for those applications, we see a scale depending on the size of the project, where for green hydrogen we see pilot and demonstrators, let's say in this size of 10-20 megawatt already built and in operation or in construction. And in the database Project Smart Explorer, we pay attention to trace all those pilots and demonstrators, because they are strategic for each one of you to be approved and qualified for those projects before then they are deployed at larger scale, where that we see 100 megawatt in this case, where we see more and more of this project already at design phase or already in construction. And those projects are also in the database, of course. And the ultimate step, I would say, are those large-scale projects to produce 1 gigawatt, which are already identified. They are still, most of them are design phase. There are very few under construction. But just to say that people start to work on that, and you will find again those projects. So pilot and demonstrator are everywhere. Mid-size industrialization, they come month per month, and those large scale start to also point out in the pipeline with a perspective to be really in operation by 2025. So that scale we see here in 2025 in that respect is tomorrow and require action right now. For blue hydrogen, I would say here is a daily business. Of course, everyone wants to decarbonate existing gray hydrogen production and then to decarbonate it to produce a blue hydrogen. So here's a brownfield business. There are a few greenfield projects anyway in blue hydrogen, especially in Asia, and because the demand for hydrogen is there anyway, and so this hydrogen has to be produced by one way or another, and therefore it will be blue hydrogen in the meantime to become green hydrogen, because here, as you understand, it's far more complex. So I'll hand over now the second part of this presentation to Jean regarding what we see as open question or pending question regarding hydrogen, and that we'd like to share with you, and we invite you to comment or raise question on this topic, of course. Thank you, Jean.
Thank you, Jean-Charles, for this first part. So, as Jean-Charles has been saying, I mean, the hydrogen market has been evolving quite strongly, and that's something we anticipated, of course, earlier, 1 year before, and even as soon as we started the energy transition part of Project Smart Explorer. No, the hydrogen market is gaining a lot of maturity, but still there are still, let's say, a pending question about how to do some part of this industry. And the first one behind is, of course, how to produce this green hydrogen, because we are not going to carry on, let's say, the gray hydrogen and consume a lot of CO2 from there, or have the blue hydrogen production. So, of course, as part of the energy transition, all eyes are on the green production of hydrogen. And here, I would like to go back to, let's say, the need of supply from those electrolyzer equipment, which is the critical equipment and critical piece into all projects, because electrolyzers requires two things. First, electricity. It requires a large volume of clean electricity. And today we are quite limited in capacity of clean electricity. It has to be said. I will not go, discuss about, let's say, the quality of this electricity, or the fact that this electricity is alternative, because that's outside of the scope. But just, for example, in terms of volume, we have about 5 times more capacities of electrolyzer, meaning we are around, for example, in Europe, 100 megawatt to 1 gigawatt project. But in front of that, we don't have the capacity to produce this clean electricity to supply those electrolyzer. So here there is a real question mark to say, okay, where is the electricity, or where will the electricity come from to supply those electrolyzer? Because if it's to use gas to produce electricity to produce hydrogen, okay, it's not really meaningful. And what we see, comparing both development of green hydrogen and green electricity, we see that the supply of electricity is clearly lagging behind because the projects are not in the pipeline, because for example, windmill offshore projects are getting postponed, etc., etc. So it will be a big question mark just for the electricity. Now, the second part about electrolyzer is also the water, because as you know, you put the electrolyzer in water, and here electrolyzer, to be functional on the long term, to limit the maintenance, etc., etc., requires, let's say, a supply of almost pure water. And pure water does not exist as itself in the nature. So it means that it requires all those green hydrogen project investment also for water treatment unit. And that's something which has been a little bit, let's say, forgotten in the first project that we saw. And many projects has been reviewed, redesigned to integrate those water treatment capacities. And it's becoming more and more a big part of those projects. And just to give you a rough idea, the electrolyzer consumption of electricity will be more or less the same as the electricity consumed to make this treatment of water, which means that, coming back to the first question that we had, first, okay, we need clean electricity, but we need clean electricity for the electrolyzer and for cleaning the water as well. So it means that we need twice the electricity. And of course, it's tough to have the capacity today of those. And then on the water picture, there might be some region where you have a clean electricity or capacity to produce this clean electricity, but in most of the cases, the region where you will have capacity of clean electricity are not the region where you find a lot of water, especially Middle East. You can have a lot of solar farms that are going to produce a lot of electricity, but you don't have clean water, which means that you will need to have desalination water, etc. project, and it will be a huge consumption. So here, big question mark about the production, how to supply the clean electricity, how to supply the pure water. The second big question mark about hydrogen that is not so much raised is about the transportation. It's quite uncertain. And here, if you remember the presentation we made 1 year ago about the midstream of hydrogen, we are saying, okay, people are trying to investigate about the trucks, about the pipeline, about the ship, how to transport this gas, and how to do it, if they need to do it into this gaseous hydrogen, if it will be liquid hydrogen, or if the hydrogen will be, let's say, transformed into a vector of energy like ammonia and then transformed back to hydrogen. It's not clear yet where this industry is going. To be honest, we are seeing tons of different solutions. We don't see a pattern that is going to replicate. There is not one technology choice, let's say, which has been made. And here, I would say the industry is still wondering. And in front of all those wonders about the transportation of hydrogen, what we see more and more at the opposite are industrial complex or other users of hydrogen, which are directly integrating electrolyzer in the process. So really next to their project with the goal to cut this transportation question because they don't realize how to do it. And they have, let's say, an easiest way to transport electricity than to transport hydrogen. And transporting electricity, I would say, is a little bit biased because, for example, they will develop project of clean electricity somewhere in the country. They will integrate this electricity to the national grid. And then on the other side of the country, they will, let's say, just take electricity from the grid in compensation to what they have been produced. So that's what we see. And more the electrolyzers are getting closer to their application. So here again, we'll see how in the coming months and year how it goes. The last part about hydrogen, but which has gained a little bit some echo on the last months because everybody was turning to hydrogen because as soon as you burn it, it's really clean. Because when you burn hydrogen, you are going to produce water. So of course, it's not harmful to the environment. But the problem was raised from the leakage of hydrogen as it is when it's not burnt. Because of course hydrogen, as you know, is really a small molecule. It's the smallest, in fact, you can have. And for ball manufacturers who are connected, you know, or for pipeline people or pumps, you know that every gap needs to be filled because hydrogen can go through everywhere and can be vented and go into the atmospheres. And here the estimation of leakage for hydrogen, as it's a small molecule, is about 9% of the production, which is a huge volume that should go into leakage. And the problem that as soon as it's released in the atmosphere, hydrogen goes above the atmosphere to the stratosphere, and those are higher level above the atmospheres, and combine with ozones to create water. And there, hydrogen become way more harmful to global warming than CO2. And that's a big problematic because as we are starting to ramp up the production of hydrogen, the idea is not to replace one gas by another if this gas is going to create a problem. And just to give you an evaluation, hydrogen is 11 times more harmful than CO2 when released and vented to the air. Which means that hydrogen has to be produced, of course, but it has to be burned, and we really need to limit the leakage that we have from this industry. I put you the link on the last study which has been made on this, because usually the number that we knew about the potential of global warming of hydrogen was about 6, but the last studies are saying, okay, it's more about 11, which is making it questionable compared, for example, to natural gas, which would be more harmful but has less capacity of leakage. So it's, let's say, a hard arbitrage to see, okay, which one would be the best for the environment again. Going out of those problematic that I leave to let's say to the industry and to the expert to solve, just for you to have them in mind. Here we are going to talk about the market, because that's what we do at the end. We're here to do business, and figures have been quite interesting on the past. So I share with you those figures and those charts that we exported from Project Smart Explorer. And a few things to detail on this slide, but many things to understand. First, from the forecast, it's quite interesting to see that, of course, it's ramping up. That's what we had in the forecast. That's what we had also in mind in the scope since day one, I would say 2 or 3 years ago. And here you see that it's booming, and it's booming until 2024, 2025. Then it's going down. It doesn't mean that the hydrogen industry is collapsing. It just reflects what we see as of today on the project going on the market, okay? Just to compare with oil and gas. With oil and gas, we may have, let's say, a prospective view of 2-3 years, which are really, let's say, good, but not, let's say, to this extent. So really, for hydrogen, we see the market ramping up. And when we look at what has been awarded, so no more the forecast, you see here 2021, 2022, you see that it's starting to get awarded for the coming years. You have here 2024, which is already a strong year being awarded. And of course, on the next coming 16 months, we'll see project getting awarded on top of that. So 2024 may end up maybe twice to 3 times what was 2021 or what was 2022. So we are really into this booming effect that we had predicted. Now, what is also interesting is to see that if we compare the chart we had 1 year ago to the one, the evaluation and the size of those piles has just doubled. Meaning that we have passed from a market that we were seeing in 2024 around 20 billion investment in terms of project. 1 year later, we see that the market should be hitting around 40 billions. So that's to tell you that even if we were looking at it as a boom, okay, over the last year, it had just doubled. So it's a huge boom, faster than what we anticipated, because all the actors are just pouring there. Now, what is interesting to see as well is who are the actors there. And you see from the scope of IOCs, meaning international oil company, NOCs, nationally owned companies, and independent, which are in green. You see that it's a market well dominated by the independent. And in fact, we see many companies coming out of nowhere. Either they are independent from the oil and gas sector, which are turning to hydrogen. Either they are startups starting in an hydrogen business, trying to develop their technology. They can be spin-off from European universities. They can be people from the gas distribution business going to hydrogen, etc. So many companies, even chemical companies, are coming to the hydrogen business, but it's not really the big names playing the game. It's really into the end of those smaller players, and it's really interesting to see, okay, who is taking the ball and who is taking the lead on those projects. Again, the last piece of information about this market is that maybe 80% of this business, for 80% of those projects, the FEED contract is converted to EPC contract to the same company. In fact, it's more let's say the investors and the operators making an agreement with engineering to develop the whole project. And of course, you have a final investment decision which is made before the EPC, but of course, it's not opening for bids, etc., etc. It's just the conversion, and it's a business that is developing this way. So it means that for you, you have to be at the FEED to be involved in those projects, to be involved in the specification, to be involved in the development, as simple as this. So that's also one key takeaway from this webinar. Now, looking at the footprint of this hydrogen project, you have the map and export from Project Smart Explorer. You know the legend. In green appear all the projects worldwide. And what is clearly happening for hydrogen is that this market is organized in hubs. Okay, the first hub and the biggest hub is Europe, and this has no competition there. Europe is for sure maybe not half the market, but almost, and around 40% of the investment of the project are located in Europe. They were all, I mean, it's not so surprising because we have seen over the last 2 years that Europe was a concentration of pilot and demonstrator project, and that's what we see phase 1 development coming also in Europe on top of those. Now, going out of Europe, we see still some hubs developing. So Texas is one, maybe the first one. The second one, let's say Egypt, Oman, Abu Dhabi, and few places in Saudi Arabia, where those countries also want to develop their hydrogen capacities. And I would say on the same level, we have China, of course, which is pushing a lot on hydrogen. A little bit behind, but catching up very fast is Australia with giant project. Australia is starting to be able to become, let's say, a global exporter, a little bit like they are doing on the gas market. And they are not, let's say, a huge player today, but they are coming with huge investment, huge capacities of clean electricity production. So, of course, it will become a huge part of the market as well. But just with those few names, okay, you cover maybe 90%, 95% of the market. So that's what you have to get in mind. About this map, there is also another part which is interesting behind. It's, let's say, the temporality of this map, because we are seeing waves of projects. Europe was, as I said, the hub for all the pilot projects and demonstrators. And today, what we see is European technologies going worldwide and going to export their licenses and their technology to all the other continents. And the motivation behind those exports are different. If we look at the exportation of those technology to US, for example, to Mexico and to Canada, the reason behind the motivation is because there is an industrial need, okay, to use green hydrogen. So that's why we see many projects going there. No, if we look at the other countries mostly in their way to development, like South America, like Middle East, and I will include a little bit bias Australia as well. Project of green hydrogen and hydrogen are going to those regions because that's where the capacities of clean electricity production are. And of course, when you want to produce green hydrogen, you need to have clean electricity. And again, in Europe, we are quite limited there. But it doesn't mean, okay, no project will happen in Europe because, as you will see, Europe is remaining maybe the first hub for those projects. So it's really interesting to see those three reasons. And also in Asia, it's a little bit the same story as in US. There is a huge need for industrial application of hydrogen. So that's why we see some license of developing Europe going there as well for export. So for one reason or another, what has been created over the last 2 years and is still in creation will go to export in all the other continents worldwide. Okay, so that's quite important for you to be on those projects, to be able to go and travel in the luggage of those licenses and reference. Now, talking about the temporality of and the geography of this project, I made an export which is a little bit complex, but I'll explain it in a simple way. We map on the left all the project where the EPC contract will be awarded before 2025. Okay, and on the right we plotted all the projects where the award should happen later than 2025 or in 2025. Why did we take this year? It's for us a balanced year, 2025, because that's where we see a little bit the transformation into the industry and again in maturity. Okay, if we look before 2025, the region of the project is well distributed: 25% in Europe, 25% in Asia, Middle East, 20% in North America, and 10% in Middle East. So you see that those projects are located a little bit all over the planet. And of course, most of the feed, and that's what you can see on the left in green, are made in Europe. Main part are also made in North America, mostly Houston. And it's still, it remains a little bit the same story for the EPC, where you see a vast majority of going to Europe, and then some part also in North America, but Asia, Middle East remaining a little bit a smaller actor on this market. This situation is before 2025. Later and after 2025, the situation is changing a little bit. Europe is becoming the biggest hub for hydrogen. Okay, even if we don't have clean electricity, we have the needs, and that's why green hydrogen project will remain for the biggest share in Europe. Okay, Europe represents 25% of the project. And investment, okay, not in number of projects, but in terms of investment. Asia will represent 25%, and then, okay, North America would represent 13%, and Africa will represent 13%, but which means that the market will concentrate in two axes, Europe and also Asia Pacific. Now, for the feed and for the engineering capacities, the situation is a little bit different. Some of the feed will remain in Europe and in US, but what will happen is that most of the feed will go to Asia Pacific, and you see from one to another that Asia Pacific is passing from 13% to 48%. So of course, it means that all the engineering capacities are going to Asia. And if we look at what the EPC is looking like, and about 80% of them are going to Asia. So it means that there is really a transfer of technology being made. Let's say, even if projects are, let's say, remaining in Europe, the licensing and the technology are today developed in Europe, and then they would be sold through license, most likely, to engineering in Asia for application. Okay, so that's, for example, a situation we have known in the oil and gas for some specific application. That's something also we have known. If you are myself, I'm a former Air Liquide, so that's something we saw for air separation, for gray hydrogen, etc., etc. It's most likely becoming the first thing where technology and licenses will be developed here in US or in Europe, and then they will go sold as license to Europe, to Asia. Sorry. So that's something, a clear picture that we see a pattern that you can export and focus through Project Smart Explorer. Now about the project dynamics, what we see, what are the trends today. Today, it's true that, projects are getting bigger and bigger. As Jean-Charles was saying, on the last 2 years, we were making projects about 10 to 20 megawatts. Today, each project which is going into design is about 100, 150, 200, 300 megawatts. So they are really getting bigger with the perspective to go in 2025 into the gigawatt scale. So we are really into this anticipation that we had. And operators and engineering are delivering this race. So you have to scale up also your capacities to attach to those markets. No, the other trend we're seeing today is more and more integration into energy cluster, as Jean-Charles was saying, from a green hydrogen project where it's more becoming, let's say, hydrogen hubs, where hydrogen will serve renewables. Let's say it would be below on the scale of renewables, and would be up from then chemical application or energy application. So it's becoming part of, let's say, a value chain of energy more than a standalone project. What we see also is the licenses being developed, and especially in Europe, where people are starting to have their pilot and demonstrator in production. And of course, they are trying to put a model of license to be able to sell those licenses somewhere else to people who will have a need. From there, this is today's trend. The trend we see for the next 5 years are modularization. Sorry, it's a tough word. As people just trying to say, okay, I will have a need of green hydrogen of this volume of production. So I'm going to buy, let's say, a module of 10 megawatt, and I'll buy this amount of module of 10 megawatt, and I would just pile them, connect them, and use the hydrogen produced from there. So that's something we see more and more. It's not actual yet because, of course, it still needs some maturity, but that's what the market is calling for. What we see also in the 5 years that the project and the business, they will remain for the project in the industrial countries because that's where the need is. But the EPC and especially the execution will be done in Asia. Okay, because let's say the technology would be mature, the license would be mature, so it will be more a game of optimizing the prices, etc., etc. And now, if we go to the decade perspective, okay, a bit more long term, the first trend that we can share with you that Middle East wants to become and they are setting themselves to become the first global net exporter of hydrogen by 2030. Today, they are not the first mover, of course, because they don't have this engineering capacities, they don't have the industrial need, etc., etc. But they want to place themselves to say, okay, we are an energy hub for gas and for oil. And if people are going to use other means of energy, we are also going to remain this hub of energy. And I mean, they have the capacity to produce this clean electricity. So, of course, in 10 years, they will have the capacity to produce clean hydrogen, and they want to become first net exporter of hydrogen. And they are putting a lot of money on the table for this. So this is the trend. If we go to the right, it's interesting to see the markets of hydrogen, because we made the exercise 1 year ago to say, okay, what will be the market, etc., etc. And of course, 1 year later, it has a little bit changed. But we see that the green hydrogen or blue hydrogen market is today firstly replacing the existing market for gray hydrogen, and that's the easiest market, of course, to achieve, but it's the most dynamic one. It's a huge market already for hydrogen. The second one, which is opening quite quickly, is also heavy industries, especially cement, steel. So those people, they want, because they might not have access directly to clean electricity, and they might not have the capacity of clean electricity, so they will turn to green hydrogen to do their application. And the last one opening is, of course, the carbon recycling, because if you combine CO2 with H2, you can simply make methanol, and there you can reuse this fluid as a neutral carbon footprint fluid, and of course, it's way profitable. what we see market not opening or not opening as fast as we may have anticipated are transportation. Road, AEV, public, airships, those markets are not opening this fast. And honestly, I mean, we don't see so many movers going there. So it's now a big question mark to see if those markets will turn to hydrogen or if they will turn most likely to syn fuel, to biofuel, or to electricity. So let's see where it goes. But at least the hydrogen is not making a huge push on those markets for now on. One of the last slides here is about electrolyzer suppliers, because many of you work on hydrogen, often work with electrolyzer companies and manufacturers, because they are a good way to enter on project. Because as soon as you start to talk with electrolyzer manufacturers, add their critical equipment in those projects, they are a good door opener for you to go on those markets. So many of you often ask us about who are those electrolyzer companies, etc., etc. And here we reference about 100 of them. And I think there is many more than that, which is not yet in our scope. We try to document those information in the database in Project Smart Explore. It's quite tough to do, but we try to have those information. And here, I mean, there is no real leader on this market. Of course, it will require a lot of consolidation, etc., etc. But it's also to give you a warning to say, okay, if you focus on some champion, of course, it will be good door opener, but it might be tough to cover all of them. Okay, so if you know them, etc., etc., it's a good door opener. Sorry, to go on this market, but it might not be the only one because you cannot cover all those companies. So one of the door that we may advise you is also to go buy the licensing and go buy the operators that you may already know, or buy the investors, because all those green hydrogen projects are made in joint venture, so you might know at least one guy in the joint venture that is able to push your product on the table. Again, if you want to use this list of electrolyzer, it's free to you, and you are more than welcome to use it to target the project that you're interested in, etc., etc. In conclusion, and that'll be the slide before going to this question, and it's a little bit a recap of what we have said, but also to give some perspective of the argument that we made. It's a slow-moving market and a long-term perspective market for transportation and for clean fuel. It's starting, but it's starting fast, at least on the syn fuel. As a fuel for transportation itself, just hydrogen itself without transformation, it would be quite tough to see it as it is. Most likely, it will be transformed again to syn fuel and then be used as a clean fuel in methanol or in ammonia, or etc., etc. At the opposite, what we see is the first market is slow. The second one about decarbonification is booming. And over the last 8-9 months, we have had a lot of information and a lot of dynamics about those decarbonation projects. Because, of course, hydrogen can be used in all those chemical applications as a block, as an intermediary to clean many operations. Now, what we see from there, and as a mean of decarbonification, we see hydrogen not replacing oil and gas clearly, but just becoming as a mean to clean oil and gas operation. And that's why we put not replacing oil and gas before 2040, but honestly, we don't see it replacing it at all today, and we don't have perspective of any replacement. What we see about this green hydrogen is coming on top of it to clean the oil and gas activities. So now, of course, hydrogen is playing a role in renewables to let's say convert and to put value and monetize the electricity produced from renewables. But it's also a huge vector of decarbonification. So we see many applications in greenfield and brownfield just to clean those applications and decrease the carbon footprint of many companies. Now, looking at the market globally, the maturity is not reached yet, and that's clear that this hydrogen industry is going to change and adapt, and that's the question we raise to say, okay, here, big problematic, big question mark that needs to be answered, but still the market has increased its maturity clearly and quickly also. I mean, in just 1 year, it's totally different, not totally, but quite different than what we had last year, and of course, it's going to increase, and you have to be part of this, let's say, push to be sure that you will take advantage of it. The period is quite good now because even if the pilot and demonstrator are, let's say, going into production, the industrial phases, phase 1 development or phase 2, which are in the gigawatt size, are starting soon. So you can still place yourself to go on those big projects, and you can be quite a strategic move to make. And as you saw on the previous slide, as pipeline of project is growing and is already full until 2025. There, the only limit is what we see of this market, of course, and the second limit is, okay, how much EPC company can deliver those projects. So for you, it's I mean, globally, it's a great opportunity to transfer, from petroleum or oil and gas application to go into this hydrogen, knowing that both goes more and more into parallel if they are not going together into some developments, especially for ethylene cracker or for refinery. The only difference is that the financing for green hydrogen is public, so it means that it has been secure on long term. For example, in Europe, they have signed an agreement to finance about 300 billion over for the next 5 years just to secure those projects. So of course, the first one to come on the table to say, okay, I've got a project, will get the money and the financing for those projects. Here again, and we can be a little bit proud as a French, I would say, but most of the opportunities would remain in EU directly and indirectly. Why do I say so? Because about 30% or 35% of the project will remain in Europe. And for those who are not in Europe, most of them, if not a majority of them, will be done with licenses developed in Europe. So one mean or another, you could really catch a huge part of this market just by being in Europe. So it's quite interesting compared to the oil and gas, where it's way more global. You have here in Europe a concentration of, let's say, door to knock for you to enter this market. So of course, you have to make it your advantage and be able to go to the right partners to move and catch some more opportunities.